Hi everyone. So what you're seeing now is a typical maxima minima problem wherein you have a lot and you are going to fence it and have some fencing materials that of course has a cost. So of course when you're buying fencing materials, you always go for something that will minimize your cost on buying it, right? So here, provided that we know the area of the land we're going to fence, the cost, how much will it cost to fence the sides, the perimeter of this rectangular lot, we can solve it in this way. So suppose these three sides of a rectangular lot here, this one, this one, and this one, cost $40, $40, and this front of our land cost $80, and the whole area of this land is equal to 2,400 square meters. How do we find the minimum fencing cost? So how? So first things first is we label the side or the sides that has similar or the similar sides, especially this is a rectangle. So from what we learned in mathematics, rectangle has two sides equal to each other, parallel and equal to each other. So if this side is the first side, then this here must be its parallel side and equal to it. So if we label that as x, then this other side right here must also be x. And then of course, the other pair is this sides. So in order to distinguish this side from this side, we label it as another variable. So if this side is y, then since this is a rectangle, this is also y. So in our problem, we are told that these sides, this side, and this side cost the same. Or in other words, it costs $40 each. So we can say that the total cost of our fencing material is 40 times this one, 40 times x, plus this one, 40 times x, plus 40 times y. And then, this front side is more expensive compared to this each side, so compared to these sides, the three sides. So that is $80 plus $80. 80 times how much the length, diba? 80y. So that's 80y. Alright? 40x, this two, 40x, then 40y, then 80y. So, first, I'll explain to you what this means. Di ba, umupalit og something, we need the amount. So, for this one, amount and the cost. So, multiplied by how many, ba? This time, our x is how many ang atong covered nga length, ba? This is 1 meter. Then, for every meter, for instance, for example, that's 40. Then, if we have total meters of 6 meters, then we will just multiply 40 to it, 40 to 6. So, that's just what this variable here means. This term means here. It's the cost of one side, depending on how much the length it has. Now that we have the cost, our next goal is to relate it to the area we are going to cover. So, as what we learned, area of a rectangle is just the product of the length and the width. So, our length here is just y and our width is x. And therefore, our area of that rectangle is just xy. And we're given with the total area, which is 2,400. So now that we have the two equations, we can now solve for the minimum cost we can get through calculus. But before that, let's just simplify everything first. So this equation, we can rewrite that as C is equal to, combining like terms, 40 mangoes plus 40 mangoes is equal to 80 mangoes. This time, 40x plus 40x is 80x. And then, this one, 40 plus 80 is 120. So that's 120y. Alright? Now, since we have three variables here, we need to take advantage of this equation we have here. So that we can have at least one unknown. Ba? So if we rearrange this, and let's have y by dividing both sides by by dividing both sides by x, we can say that y is equal to 2400 over x. So since y that is equal to this y, we can substitute that there. So that would become 2400 over x, and then plus this value. And now here's the most important part. Since we have this and we want to minimize the cost, this cost c, we will differentiate this with respect to this variable inside. So how? Let's just differentiate it based on the formula we have. You can Google it, or I guess you have the notes already. So the derivatives of term by term. So this term, derivative of that is 80 plus, if we bring this out to 400, it will become 120 times to 400, and then the derivative of 1 over x, or the inside function, would be negative 1 over x squared. So it's just a matter of formula, guys. You can search for it. Okay, so now we have the derivative of our function. So with that, if now that we have the derivative of the function, we'll just have to equate it to 0. We'll just replace this one by 0. So why are we going to replace that value with 0? This is the most important thing right here, replacing dc dx by 0. So just remember that in calculus, if we have a function and it's represented by somewhat like this curve, so this is a function. So let's say if this is y and this is x, this is y as a function of x. So when we say derivative of a function, it implies the slope at every point of this function. So let's say at this point right there, it has a tangent line like that. So that right there is the slope of the line tangent to the curve at this point. Also, if we want at this point, it also has a slope right there. So basically, if you have a curve, it has a different slope on every x values, or on every point right there. On every point, let's say at this point, it has its tangent line, or the slope at that line. So whenever the slope becomes 0, in that special case, our slope is either at the maximum point, or this point right there, or right here above. That's why this dc dx that we have, that's the slope, right? That's the slope. That is why we are equating it, or we are replacing that 0, because when dc dx becomes 0, it becomes somewhat like this one, right? The tangent line becomes horizontal, and thus it has no slope. So this one 0 slope, this one has slope, this one has a steeper slope. But when the slope becomes horizontal, the slope is 0. So when the slope becomes 0, then we can say that our function is maximum on those points, right? So going back to what we have a while ago, if we replace this dc dx by 0 and solve for the value of x in this one, that value of x, it's up to you what strategy you're gonna use. You should get x is equal to 60. We substitute this value. Now that we have that x equals 60, this is 60 right there. So this should be 60 as well. Now that we have the length of our one of the sides, the measure of one of the sides, we just have to substitute that to this equation we have, this one, to solve for y value, and we should get y is equal to 40. So if you multiply 60 by 40, that should be 2,400 at least, diba? Equal. That should be true, 2,400. Now how much is the cost? So for the cost, we will just substitute the x on this one, on this formula, on this equation that we had. We substitute x here, which is 60 that we have. Then the cost would be $9,600. So this is now the the minimum cost, minimum expenses that we will have when we are going to fence this lot having an area of 2,400 and having a cost of 40 for the three sides and 80 for the front. So now, how do we check if our answer is correct? If we satisfy that this is the minimum cost, how do we know that this is really the minimum cost, minimum expenses? So let's explore our given again. So still, the price is $40, $40 on this, 40 on this, 40. So now let's explore. What if our what if one of the sides becomes 50? Let's say x equals 50. Provided that the area remains the same, of course, that doesn't change. Then when x is 50, then y becomes, or y is equal to 48. So our one of the side, so our dimension would be 50 by 48. So let's look at the cost. How about if x is 50 and y is 48? How much will be the cost? Using the same equation that we have above. So that is 80x plus 120. So substituting here 50. So what we did is make this length lesser. Then we will get a cost which is, so the cost will become $9,760. So you can see this is bigger than what we get. So this value is more expensive than this one. Our first answer is only 9,600, while our new value when x is 50 or one of the sides is 50, we get 9,760. Right? So it is not minimum. So 50 will not give you the minimum cost. So again, let's try another value. So a while ago, for 60, it gave us, so this is the equation for cost. For 60, it gave us 9,000 plus 9,000, this is 60. That's 9,600 as our total cost for fencing. So now, how about if we try this time? So if we try lesser than 60, a while ago that's 50. So now, what if we try greater than 60? Let's say 70 meters at x equals 70. What would then be the cost that we'll have? As you can see, that's 9,714, which is bigger than 9,600. So as you can see, based on these three results, with x equals 60, we will have the minimum cost, which is 9,600. So that's how you solve maxima minima using differential calculus or the derivatives. So all you have to do is find at least two equations, or I guess one or more equations, that will describe that will utilize the given values, such as this one, the cost and the area, that will utilize that, and also an equation that you're going to use to maximize or minimize something, ba? Just like this one, we have two equations. The equations are the equations for the area, which is xy, and the equations for the cost. And since we want to minimize the cost, we will differentiate the cost, not the area, right? So I hope you got something here. Thank you so much for watching. Peace out.